What is up? I'm back. Unfortunately, no stream yesterday, so the streak's over, but not too worried about that. I'm just trying to keep up the overall consistency. So this is day 10 of live interview prep. I guess I should put daily in quotes now because I did miss one. So now we're in day 10 of quote-unquote daily live interview prep. But yeah, back for more. Clash of Code, Codewars, LeetCode. There's at least one problem in AlgoExpert that I'll solve. What else is there that's worth saying? Oh yeah. Unfortunately, I started the stream later today than I had planned, so it's not going to be a particularly long stream. In fact, it's going to be probably like an hour and a half, so I'm not sure how much stuff I'll be able to do in that time. But my girlfriend bought concert tickets for tonight, so I need to leave the stream so that we can go and get to the venue and all that stuff. I'm actually pretty hyped for it. It's going to be the Red Hot Chili Peppers, and I've never seen them live before, so yeah, I mean, I've been listening to their music for years, probably since like middle school, which was, how long ago was middle school? 2004. So yeah, a long time. So it'll be hyped to see them in person. But yeah, so without further ado, let's start off with some Clash of Code. Also, if anyone feels so inclined, I did change a few things about my my audio setup. So if anything sounds better or worse or weird, I guess weird would fall under the category of worse. Please let me know. Hopefully everything sounds okay. Okay, so yeah, let's just join a clash. Alright, so we're in the lobby. We're in the clash lobby. Okay, we got some people hopping in. Anyone's welcome to join the clash. So the other day, 2 days ago when I streamed, I did 3 clashes, and I'm not expecting to do as well today as I did 2 days ago, where I ranked 1 out of 7, 1 out of 6, and 1 out of 5. Like generally, my performance looks a little bit more like this. Like here, you can see I got 2 out of 6, 3 out of 8, 7 out of 8. But yeah, I did really well on Wednesday. And yeah, now it's Friday, so we'll just see how it goes. So I could launch the clash now. Let's just wait, see if we can get a full lobby. So in AlgoExpert today, I will solve this problem, cycle and graph. I think I know already how to do that. Then there's this DP problem that I had started to work on Wednesday and did not finish. Oh, okay, starting. Here we go. Fastest mode, shortest mode. Alright, well, let's see. What does it want us to do? The bomb suite sequence is an infinite automatic sequence of zeros and ones defined by the rule B of n equals 1 if the binary representation of n contains no block of consecutive zeros of odd length. B sub n is 0 otherwise. For example, B sub 4 is 1 because 4 is 100 in base 2 and doesn't contain a block of an odd number of zeros. Your goal is to compute the bomb suite sequence for all the integers in the range provided in the input. So you get 1 to 3, and you're supposed to produce 1, 0, 1. Okay, so let's see here. I'm just gonna get it working because this is shortest mode. So I'll try to get the algorithm working, and then after that, we'll figure out how we can make it as short as possible, which will probably involve switching languages to Python, I imagine. So we get our low and our high
And then for int I equals low, I is less than or equal to high plus plus I. We're gonna have it's gonna be faster to print them in a, to put them in a well, for now let's just do this. So if I is not equal to low, then we'll see out a space. Okay, then at the bottom we'll see out an end line, and then in here we'll figure out the answer, and then we'll see it out. So we need to iterate through the binary representation. So in Python, for example, can't you just use like the bin function to grab that? Maybe I should be doing this in Python just right away. Because what I was gonna do in C++, especially if you want your code to like run fast, you can do math to get the binary representation, right? You can just keep doing, you can keep taking the number mod 2, and then you know if like the next binary value in the binary representation is a 0 or a 1. But I think probably the shorter solution to this problem is going to involve just doing binary, just converting it. So let's see here. So yeah, let's call them L and H for low and high. We can already start to just do a little bit of this stuff. And then for I in range low, high plus 1. Oh, those are L and H now. So in that range, oh, so this should be like the short, well, at least one way to do it shorter would be to do this as a list comprehension. And then you can do empty string.join that. So that's probably what we're going to want to do. And then this is going to be, okay, someone submitted in Ruby with a code size of 272. Pretty sure we're going to be able to beat that. Hold on, how do we get the, so Python int to binary string. Is that how you do it? No, there's a, here we go. Bin, just bin, dude. But then we need to do substring from index 2. So it's bin of I. So if I run that, yeah, we get that. So let me just review the requirements. So it's 1 if there's an odd number of zeros. Okay, so we do need to substring it. So we'll do 2 colon, play all test cases, and now you can see we're getting the actual binary representation. And now we just want to see if
what's the easiest way to do this? If there is an odd number of zeros total, does that mean that there's definitely a substring with block of zeros of odd length? I think yes, right? What about the inverse of that? If it has an even number of zeros, then there could still be blocks of odd length. So I think we have to check all the blocks. I wanted to see if I could shortcut this and just like count the total number. I'm trying to figure out how to not blow up the code. So I could have like a function, right? Get we'll just call the function g of this. I don't think we're gonna need any of that. So def g of x. And so now we want to iterate through. Okay, I'll just write the code and then I'll try to think about how I can make it smaller. So prev equals -1. We gotta make this shit short. P equals -1 for C in X. Then we have to have the type. This is the type. So the type is -1. I'll try to explain this in a sec. And then the len will just be L is 0. Then for C in X, if C is the current type, then then L plus equals 1. Else, then the type is C, and L equals 1. Oh shit. L equals 1. And then down here, if C equals 0 and hold on a sec. Oh, we gotta check it when we reset. So else, so if the previous type is a 0 and the length mod 2 equals 1, then return. Then that means we found a block of odd length.
So we return 0. And then after we finish all that, we return 1. What happened? What happened? What's wrong with this? Wasn't this like just working? Argument of type list int cannot be assigned to parameter iterable. Oh, it needs to be strings. Okay, so we found... Okay, so for... two... Well, I have 2 minutes to fix this. So I might not pass at all if I can't do that. So we're expecting a 0. So let's print x. So for 1 0, which is the binary representation of 2, there's down here we need to do this check one more time. So this can just be okay, so we might be gunning for a second place now. Okay, we're passing the test cases, but our code length is 321, and the person who's in first place right now solves it in 272. So I only have 40 seconds left. I don't think I'm gonna be able to do it. I want to make sure I don't miss my opportunity to submit. So what could I do? Like maybe this condition could move into a function. But I mean, we really need to trim off like 50 characters. It's not happening, so I'll just submit. This is probably the best I'm going to be able to do. So that brings me in at second place, at least for now. 10 seconds left for 5 more people to submit. Oh my god, Anon came through with Python 3, 120 characters. Yes, we will definitely be looking at that. That's kind of insane. So first, the person who submitted the earliest solved it in Ruby with 272 characters. Okay, so this is their line of code for getting the in. So then they... Oh yeah, this is how you make a range in Ruby, right? I forgot about that. That's nice. That's nice. So how'd they do it? So first of all, they create the range, then they go through it. They convert everything to base 2. They get the chars out. Then they do chunk. I'm not familiar with chunk. Oh, is that just split? Okay, well, then they filter by... Oh, does chunk? Shit, does chunk literally split it up into the blocks, bro? Ruby chunk.
That's nice. Man, I gotta start doing these short ones, shortest mode in Ruby. Module enumerable chunk. Yep. So in Ruby, you can do that in one function call. Split it up into blocks using chunk. That's nice. I'll definitely have to start trying to solve some of these in Ruby. So that after they chunk it, they filter by the ones that are zeros. They check to see if the size is odd. Okay, that's awesome. Okay, so let's see. I'm not going to look at all these solutions. I do want to see how the Python 3 solution was 120 characters long. Okay, so xy equals map int input dot split. Print. How did they... Oh, they replaced all the ones with spaces and then they split. Then they turned that so okay, yeah, so like they create the binary representation, they replace all the ones with spaces, they split, and then then they can just get the lengths of the substrings. Like, okay, wow, nice. All. So basically, oh, so smart. They actually use the modulus to determine whether it's going to be 1 or a 0. Not sure what print star does. Does that automatically join for you? I'll have to try that. That must be what that does. Okay, so that was cool. How are we doing on time? Not good. Let's do one more clash. Actually one clash for today is good. I'm doing a shorter stream. I'm in a little bit of a rush. I do want to get some like interview-ish coding done, so let's see. Yeah, I think I'm going to jump right to this. So this is AlgoExpert cycle and graph problem, and I think I know how to solve this using a DFS. This will be good. So we get in our adjacency list of edges, and we're gonna have a DFS. So I think it's gonna be a bool. DFS is gonna take the edges. So the graph that we're given is a weighted directed, it's an unweighted directed graph. It doesn't say it's a tree, doesn't say it's a DAG, so that's why we have to have our full visited set. So I think we can do unordered set of visited, unordered set of int visited. And then that we actually need a second set, which is like unordered set int on path. And so basically what we're doing is, as we're DFSing through the graph, we keep track of the nodes that are on the current path, but once we remove nodes from the current path, those become then fully visited. So they move from the on path set into the visited set. So both of these need to be passed in to our DFS. And they need to be reference variables. There's other ways to do this too. Some people like to think of this as coloring the graph as you go. So like for on path nodes, you'd give it a new color like blue.
And then once it becomes fully visited, you change its color to red. Like that approach works too. Having two sets also works. There's, like I said, a couple of different ways you can go about implementing this. Okay, so now we need to go through all of the nodes and DFS the graph. So it doesn't guarantee that the graph is connected either, which is why we have to start the DFS from every node. So int u equals 0, u is less than edges dot size, which is edges dot size is the number of nodes in the graph. Not the number of edges, so that line of code reads kind of weirdly, but you know what I would actually do usually is I would call this ADJ, which is short for adjacency list, because that's what that is. So we iterate through them all, and we just DFS. So we DFS adjacency visited on path u. So, and what we'll do is, if we'll have the DFS function return true if it encounters a cycle. So if we call this function and it returns true, we return true. Otherwise, we'll DFS the graph all the way through the graph, and we'll ultimately return false. Hold on a sec. You're given a list of edges representing an unweighted direct. Oh, okay. So the graph is directed. I was thinking that if it's undirected, like I was wondering if we need to create the inverses of all the edges that they give us. But if it had been undirected, they might have just given us that already. Like they would give us the full graph with edges in both directions. So first thing to check is if we've already visited here, we can return. If and we need int u here as well. U being the index of the node. So if we visited, we can return false, because we already went there and we didn't find a cycle when we went there, so it's just false. Then the next thing we do is however, if u is on the path though, if u is on the path, this is actually return true, right? Because we know that we have not visited u before, but u is on the path of like the current branch of the DFS, so that means that there is a cycle, so we return true. Then, after checking both of those cases, we put u on the path, and then we go through all of its children. So for int b of adjacency list of u, and then this is going to be the same thing as what you saw below, where if we DFS to v and that returns true, then we need to return true from here. So as soon as you find the first true, your whole DFS unwinds and you return true from the very last call, which will then come down here and will return true from the solution function. So we DFS adjacency visited on path and v. So if that returns true, we return true. Then, now that we've explored the whole graph from u, if we didn't find any cycles, then we remove it from the path and we set it as visited. And we return false, because we did not find a cycle.
And then this is kind of where the like coloring thing comes in, right? Like you could have a node color where you turn it to like yellow when it's unvisited, and you could turn it to like green when it's on your path, and you could turn it to I don't know, purple when it's visited. That works too. Okay, run code. What happened? Oh yeah, we can't do visited u. We have to do visited dot count u and on path dot count u because C++. Yeah, and then this is actually because these are not maps or like vectors, these are sets. So this just needs to be on path dot insert u, and then down here this is on path dot erase u, and this is visited dot insert u. Okay, so just like that, we pass all the test cases, so we can submit the code. Cool. So that's how you do it. This is just the complexity of time complexity of a DFS, which is v plus e. So you're gonna go to all the edges at least once. Well, at most once, right? You're gonna go to through all the edges at most once. And then we also have like loops where we're going through the vertices. Oh, that's interesting. So they had pound included vector for me, but when I went and started using unordered sets, it didn't complain that I had not pound. I'm surprised I didn't have to do this right here. So I assume that what that means is that they have like a list of, like a semi-exhaustive list of imports or includes that you just can't see or something like that. But then if that's the case, like, why do they need to put vector there? Does it work without that? Yeah, it works without that. So they don't need to have include vector there. Vector and set and probably a bunch of other stuff is already on their list of pre-included stuff. Okay, so that's the cycle and graph from AlgoExpert. That was pretty straightforward. What's the time now? Okay, I still got some time for some more stuff. I'm trying to decide because this one I'm a little intimidated by, not gonna lie. And so I'm worried that if I start to invest time in this one, that I won't finish it before I need to end the stream, and that will be very unsatisfying. So let me just have a quick look, see if anything stands out. Like maybe I do know how to do this. Given an integer array nums, find the maximum length of a subarray where the product of all its elements is positive. Okay, so a subarray, yeah, we got that. Okay, so then I started to ideate on how I might DP this. So I created my DP of size n, and then yeah, so the way that I'm thinking about it, at least initially, I'm not entirely sure if it's going to work, is that dp of I is the max length of the subarray ending at I with a positive product. So we're going to have a base case. Well, so what's dp of 0? Well, it's going to be a ternary, depending on what num0 is, right? Num0 is greater than 0, question mark? 1, 0. So if the first index is a positive number, then we have 1 as our starting base case. Otherwise, it's either 0 or it's negative. Both times, it's not one of the subarrays that we can qualify. And then, as I'm going through, I'm going to be updating my answer, I think. So answer is the max of answer and dp of I. And then I can also, I need to handle, you know, what if the positive number in index 1 is the answer. So we get that. I has to start off at 1 now. Okay, so let's try to think. I don't, like I said, I have no idea if this is going to work or not, but so how would we want to dp of I. So nums I is going to give us a positive number, a negative number, or 0. If we have a positive number, then if the max length of subarray. Oh, okay. So maybe the way to do this is similar to the problem that I solved yesterday. Maybe dp of we have two arrays again, where one array is keeping track of the maximum length of a positive product subarray, and the other array is keeping track of the length of a negative product subarray. Because then if you encounter a negative number, then you, whatever the, if you have a long subarray ending at the previous index that's negative in product, then you know, you'd multiply by the new negative number, and it would give you a positive product. So that's probably how we need to do it. So let's rework some of this to move in that direction. So vector of int dp2 of n, where dp1 of I would be the max length of a subarray ending at I with positive product, and then dp2 of I is the max length of a subarray can't type at I with negative product. So then we would have dp1 of 0 would still be that. dp2 of 0 would be 1 minus dp1 of 0. Oh no, it wouldn't. It's only 1. Yeah, it's only gonna be 1 if we're less than 0. Like that. And then yeah, the answer still starts off at that. Okay. So in my solution to the dynamic programming problem yesterday, I had a special case in my DP updating loop for when nums of I is 0. Because the thing about 0 in this problem and also in yesterday's problem, or not yesterday, but Wednesday's problem, zeros, like any zeros anywhere, regardless of if it's a single 0 or a block of consecutive zeros, it like cuts your input into smaller cases. Because it's not possible for a product, a subarray, it's not possible for a product of a subarray to be anything other than 0 if there's a 0 anywhere in that subarray. So I guess I could handle that case explicitly here. So if here, let's do what I did yesterday, where I created an int like this. So if x is 0, then dp of I is 0. dp1 of I is 0. Also dp2 of I is 0. Otherwise, x could be greater than 0, and we'll have a case for that. And then the last possibility, obviously, is that x is less than 0, and we'll have to handle that case. And then after we handle all those cases, we just update our answer. So dp, if x is greater than 0, then our longest positive and negative subarrays ending at I stay the same. So in this case, dp of I, dp1 of I equals dp1 of I minus 1 plus 1. So we're increasing the length of it by 1. Similarly, dp2 of I is dp2 of I minus 1 plus 1. We're increasing the length of it by 1. And then this case here, for when x is less than 0, is similar, except that we take the value from the other array. Oh yeah, and then this is hold on, this right here is dp1. Then here we need another max. Oh no, we don't. We only care about positive product, so this is dp1 of I. Okay, so we pass. Let's see, do we pass all of the example test cases? No. And I think that's because... Okay, let me just copy all the test cases into a notepad file. Oh, hey, what's up? 360, no hope. Nice username. Leverage prefix sum for this, but I guess prefix product. Yeah, that might be another way to do it. So just for context, I solved a problem 2 days ago, which is very similar to this. This is kind of like the same problem with like a twist. Yeah, so I solved maximum product subarray. And it's similar to the other problem, except in this one, you're supposed to find a contiguous non-empty subarray that has the largest product. And so I had the same thing where I ended up rewriting it at the end to be more space efficient. So I started off having DP arrays. Oh, you remember it? Cool. And then I rewrote it so that it just keeps track of the last. So I handled it by keeping track of like the longest subarray with negative product and the min subarray and then the max subarray that we've seen so far. So I was kind of trying to do the same thing for this one, but I'm not saying that prefix or suffix product is not a way to approach this. That's just not the direction I'm going down right now, but that might work too. After I hopefully get it accepted, I'll take a look at the discussion and see what some of the other solutions are. Okay, yeah. So back to these test cases. Also, welcome to the chat. Appreciate you hopping in. I'm doing these streams
more or less daily for now, because I'm trying to prep for technical interviews. So, yeah. Okay, so I'm failing. Let's see. I'm failing this test case, and also the third one. But let's look at this one first. So I'm saying 4, the expected answer is 3. So why am I saying 4? I'm saying it's too long. Okay, so I think the move here is to use the debugger. So let's set our breakpoint. You're also prepping and you thought about doing LeetCode streams? Yeah, I mean, man, you know, why not? I've had people coming in, you know, chatting about the problems, giving suggestions. Yeah, I mean, it's been going pretty well. I'd recommend at least giving it a shot. And thank you for the follow. Appreciate that. Let me know if you start streaming. I'll give you that follow right back, and I'll come check out your stream. So I'm not planning to do LeetCode streams for forever. Like once I get a job, I'm probably gonna just tone down the amount of LeetCoding I do. So I'll probably still do like some problems here and there, and especially like I'll review the problems for the weekly contests on LeetCode and stuff. But at that point, I'll try to get into more of actual software development. Like maybe I'll start building a game or something. Okay, so in the debugger, we're at the first iteration. I is 1, X is 1. Okay, so both the DP arrays are all 0. And then our answer is 0. Okay, so then and what are we going to get here? We're going to get that it's positive. So we're going to go into this one and okay, that doesn't look right. So the update that I made to DP1 there looks right. The update that I made to DP2 doesn't look right. I think I only update DP2 if it's non-zero. Is that right? Is it, okay, so I think I only update DP2 here if the previous index is greater than 0. If DP2 of I minus 1 is greater than 0. Dragon96 Gobi, thank you for the follow. Appreciate that. Welcome to the stream. Usually my streams are a little bit longer than my stream today will be. I'm gonna have to go in about an hour, maybe a little bit less than an hour, but I'll try my best to solve this problem in that time and then maybe look at another one after that as well. But yeah, I usually try to go for like between 2 and 4 hours on the upper end of that, and today that's not quite gonna happen, I don't think. And then that means that on the negative side, we only update the positive length if we're building onto an existing array, maybe. So if DP1 of I minus 1 is greater than 0, okay, I can just do it like this. Oh no, wait a second. I think these lines of code are right. So if it's negative, what we're doing is we're flipping it. So
So this might be like this. Honestly, not entirely sure, but we check to see if okay, so that passes that test case now. What about all three of the test cases we know of? Okay, so we pass all three of the test cases that we know of, the three examples here. So the question is my solution right? If so, then I'll just submit. Or I could sit here and stare at it and try to decide if there's another test case that this will fail. Let me try to reason through some of this logic though. So if the current number in the array is greater than 0, then we know that we're either adding onto or starting a new positive subarray. So this is right regardless. So we don't have to put an if statement around this. Yeah, you're probably right about that. So the first if branch probably is, yeah. However, if we got a positive number, we want to only increase the size of the negative product subarray if it's already greater than 0, because it's not a negative number. So if it's a negative number, then we can increase it anyway. Yeah, okay. I think I'm gonna submit. Oof. TLE? Why is this taking so long? I mean, this can't be TLE. This is a linear time solution. Is LeetCode just borked? Okay, I'm gonna refresh the browser window so that the browser. Oh, okay. Wrong answer. Okay, so luckily I can see the test case that it failed on. So this is our latest and greatest test case that we need to pass. So for this test case, my output is 2. The correct output is 6. So let's see here. 16, -5. Oh, wait. So the 0 basically stops it. So you got -5. Yeah, it's this whole thing. This whole suffix of size 6 is the subarray that has a positive product. And okay, so my code isn't discovering that. I think I'm gonna debug again. So okay, so we start off with a 1 here in DP2. That's right. Yep. Okay, and that's why you were saying this if statement is redundant. Yeah, I can get rid of that. So what's next? So we're index 2, we get -5. We get -5, and so we're here. And what we want to have happen is we should be starting off a negative subarray, a negative product subarray. Yeah. Okay, so step over. Okay, yeah, that's wrong. So these two lines of code ran, and what we want to see is we want to see a 1 right here, indicating that -5 starts a new subarray that's negative in product. So these if statements didn't work. What happens if let's try to figure out why. So which one of these would we expect to so we want this to happen. dp of 2 of I is going to be dp 1 of I minus 1 plus 1. So that's saying that we're taking the length of the positive subarray and we're... Oh, you know what? Maybe these two if statements might not be necessary. Let's see. So let's run the code without those. Okay, so... Oh, you think we just have to remove this one? Let's see what happens if we just remove that one. Okay, yeah, it might be right that we just have to remove both of these. That makes it past that test case. I can paste all of my test cases back in and make sure we're passing them all. We are. So we submit. Sheesh. Still not right. Still not right. But we are getting past more test cases. So let's take a look at this test case. So we're close on this one. We're saying 9, but it's supposed to be 8. So where's the answer at? So it's gonna be, so we got zeros here, we got a 0 there, so it's gonna be probably this. Oh, so I think what my code is doing is it's getting to 8 with all these. It's getting to 8. But then it's adding this on to the end. So hold on. So we've got negative, negative, negative. So that's currently negative, and then the negative 12 flips it back to positive. Okay, so I think the move here is to debug, but I kind of just want to debug this last part. So maybe what I'll do is I'll make a custom test case that's just this last part. So I can delete all of this. And yeah, basically I just want to look at this last segment. Let's make sure that it still fails for this. I think that it will. Only set 22 if previous is positive number. Okay, I see what you mean. Okay, I see what you mean. Oh, that's weird. So it actually passes that. It needs. It passes that, but wait, but the zeros are supposed to reset everything. But it doesn't pass this. Okay, so what I need to do is I need to keep going until I is equal to like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically till I is like 10. So we'll just hit continue like 10 times. Okay, so I is 10, we have x 0, and here's our array so far. So we did, according to the DP array, we found a subarray of length 5 that's positive. Oh yeah, we did. So these first 5 in the input form a subarray of length 5 with positive product, so that's good. So then what happens next though? So we jump over the 0 case, now we're on I equals 10 and x equals -7. Okay, so importantly, we need to see what these two elements of the DP array start off as. So it's negative, so we come down to these, and I think this, I'm probably about to get to what you just said. So, oh yeah, you're right. Yep, so I set the length, of the positive subarray to 1 when it should not be. So I only want to do that if we have a positive subarray already. Yeah, you're right. So I'm mirroring the other if statement. Is that what you're saying? So stop the debugging. So I just wanted to discover that in the debugger, but you had already figured it out. So if, oh, it's, yeah. So this needs to be, if we already have a positive subarray, right? If dp of I minus 1 is greater than 0, is that right? Oh, dp1, if dp1 of I minus 1 is greater than 0. Oh, you're good. Thanks for being in the stream on your phone. Let's run code. It's failing the test case. DP1. Oh, wait. No. This is DP2 here. That passes. So basically, if we in the last index, we're ending at a subarray, a negative subarray that has non-zero length, then we can increase the length of our positive subarray. Yeah, that's it. So and then this mirrors this, because this is basically the same case but for negative numbers. That feels right. Let's run it on all the test cases again. Okay, we passed all the test cases we know of, so submit. Hey, there it is! Thanks for the help. 360 no hope. So we passed that one, so that's good news. The reason that's good news is because DP is something I'm trying to practice and improve on. The only way to do it is to grind it out, you just gotta do the problems. And so LeetCode has this ultimate DP study plan that I'm going through. There's 4 levels. There's like level 1 through 4. I'm still in level 1 of it. And so I'm making my way through. So day 1, Fibonacci, day 2, climbing stairs. So I've made it all the way through day 5 now. And the problem that we just solved, oh wait, no. Day 6. The problem we just solved was maximum length of subarray with positive product, and then the previous one was maximum product subarray. Oh yeah, space-time complexity. I can go look at that. What I was gonna say though is up next, not necessarily today, but at the latest tomorrow, I'll start looking at these right here. So we've got best sightseeing pair, best time to buy sell stock. This is actually the start of the best time to buy sell stock series, because there's like 4 or 5 problems in it. You can see they're all right here. But yeah, space-time complexity of maximum length of subarray. I mean, it's linear in time and it's linear in space. So we can make it constant in space if we want to. So this is O of n time. The reason is because we just go through every element in the input once. and we're doing a constant amount of work for every element in the input. The constant amount of work just being updating the indices of the DP array and keeping track of the best answer we've seen so far. Dragon96, can this be done with one DP array? Good question. I don't know. I don't know. So right now we're using O of n space, but we could make it at O1 if we want to, by just keeping track of the last element of each DP array. I already went through the exercise of doing this on a problem yesterday, so I'm not going to bother. Yeah, you're right. Well, like I said, I did that yesterday on the similar problem. Like, you just basically, instead of having two DP arrays, you have your previous one and your previous two, and then in your for loop, you just update those. And yeah, I guess it would make a small improvement on the space usage here. So what I can do though is let's see if it's possible without having to keep track of two values. So let's just go to the discussion and see. So I've got it sorted by votes. So let's take a look at what this person did. Yeah, this person is doing the same thing. He's got he's keeping track of his positive length and his negative length. It might be the case that that's just the way to do it. Oh, this is an interesting solution. Oh yeah, so this one is not even really DP. This one is just finding. It's basically taking the length of subarrays between zeros and figuring out how many negative numbers are in there. It kind of like occurred to me at one point that you might be able to do it something like this, but I solved it as a DP anyway. So they keep track of the index of the first negative number. Yeah. Yeah, anyway, I feel like this one is actually harder to implement than DP. Like, DP is just pretty straightforward. LeetCode.io. I'm not familiar with that. Let me open that up. Oh, interesting. What is this? Oh, this just sorts your problems by topic. So I could, okay, let's do, I don't know, graphs. Oh, cool. Okay. Number of islands. Number of islands sounds like a DFS, BFS, or union find. Number of connected components in graph. Have I solved this one? No. You have a graph of n nodes. You are given an integer n and an array edges where edges I indicates there's an edge. Return the number of connected. Oh, okay. Well, that's a fun little. So this to me looks like a DFS would solve it pretty quickly, and since I don't have a ridiculous amount of time left, I might just knock that one out. Because I'm not going to do this problem. I'm not going to do this problem. So I solved this problem already today. This is cycle and graph, which is also a pretty straightforward DFS. Yeah, DFS count. Yeah, let's just do it. So you get your adjacency list, and let's see, everything's 0 indexed, right? It looks like it is. Oh wait, no, this is not an adjacency list. This is a list of edges. So the first thing I would do is convert the list of edges into an adjacency list. Yeah, I'll keep an eye on LeetCode. Like, I don't want to overwhelm myself with too many study plans because I'm using, I'm using AlgoExpert, and I'm using some of LeetCode's like built-in ones, like the one that I just talked about, which was the DP study plan. But yeah, LeetCode looks like it could be useful. So like, yeah, this study plan, they also have, they've got these study plans here. But as far as condensed study plans go, like you said, maybe this is the way to go. Oh, AlgoExpert, I'm a big fan. It's the problem. The only thing is it's kind of expensive, but I would recommend it to anyone, honestly. E of edges. It's they have video solutions for everything too. So the nice thing about AlgoExpert is depending on what kind of like interview prep you need, they also have a whole section about behavioral, and they have a whole section about system design. So usually, depending on like if you're trying to interview for a big tech company, you'll need to have all three of those down. You know, you'll have to be able to solve your coding challenges, you have to be able to answer behavioral questions, and you'll have to be able to do probably at least one system design interview. And the thing I like about AlgoExpert is it just puts all that stuff together. And it's, in my opinion, it's worth the money because you spend $100 to get it for a year, but then if you land a ridiculous job, like it's already paid for. You know what I mean? Like it's like pocket change at that point. So adjacency list of E0 dot pushback E sub 1. System design. Yeah, I went through AlgoExpert system design stuff before in preparation for interviews previously. So systems expert, content, systems expert, system design fundamentals. So basically what they have is they have all these topics, client server, network protocols, storage, latency, throughput, availability, caching, proxies, load balancers, hashing, relational databases, key value stores. They've even added some stuff here since the last time I did this. Like, what is this? Specialized storage paradigms. That sounds useful. Security and HTTPS and API design. So like, if you like get all this shit down, like you study this, you'll be fine for a system design interview. The other thing that they have as far as system design goes, so they have all those topics, but they also have example questions. So, for example, if you go into a system design interview, you might get an interview that says, "Hey, design Google Drive," and then it's just you have to be able to design it. But on AlgoExpert, they have video solutions. So like, this is how long is this? This is a 45-minute video where someone answers the question how to build Google Drive. So the way I did it last time, and I'm probably going to do the same this time, is go through all the topics, but then just like watch all those videos too, because they help you kind of understand how all the components go together. Okay, so I have an adjacency list. The next thing to do is just to have a DFS function. Also, because this is an undirected graph? Undirected graph, so I have to create the inverse edges as well. So I also need to do E1 pushback E0. Very important to distinguish between those two situations. And then I'm gonna need some more stuff. I'll need to know who's been visited. So a vector of bool visited of size n, where everything starts off as false. That's basically it. So then I'll have for int u equals 0, u is less than n plus plus u. And then I can just DFS with the adjacency list.
Like I know exactly how to do this one, so it's not really a good challenge for me. I should be doing problems where I'm a little bit more challenged, like the last one where I had to sit there and stare at the code and figure out why it wasn't right. But I don't have a lot of time left on the stream today, so I'm just going to try to do some easier stuff for review, I think. This problem is pretty straightforward. You pass in your visited array, and int u, oh no, not int u, sorry, just u. So that's the node that you're DFSing from. And we'll have to keep track of our answer, so int answer equals 0, return answer. We'll probably end up passing that into the DFS as well, but let me just, oh wait, this is this is the interface. So these go up here. That's why I typed int u. Then down here I pass in the just adj and visited. So importantly, if visited u, we can just return. Then visited u is true. Yeah, I think I do pass the answer in here. Oh, no. The easiest way to do this is going to be have the DFS function return a boolean. So, and then if it returns true, we increase the answer. That's one way to do it. We could also just check to see whether u is visited right here before DFSing. But I'll just do it this way. You know, I changed my mind again. If I'll just check this here. So if we visited this node already, we can just continue. Otherwise, we do the DFS and we increase the answer. This will definitely work. And then I can get rid of that. And now DFS is actually void. And now it's really easy. For int v in the adjacency list of u. If it's not visited, then we DFS there. This looks right. Yeah. This looks right. Syntax errors? None. Do I pass all the examples? I do. Submit. So that's a quick one. That's a quick one. Time complexity O of v plus e. Same for any problem that just does a single DFS. Okay, what else? Okay. Let's take a look at the LeetCode again. I have less than 30 minutes left in the stream, so I'll try to find a problem that I can solve in that amount of time. Thanks for watching and for hanging out and being active in the chat. So let's do a different category. Heap and priority queue. Pardon me. Math and geometry. Bit manipulation, it's always fun. Number of 1 bits, single number. Oh yeah, these are all easy. Tries. Implement try, design, add, and search word data structure. Word search 2. Actually, word search 2 I solved the other day. So
Coming here, you can see that on July 25th, I got this one. It's a try and a backtracking solution. Spiral matrix 1, 2, and 3. Okay, let's take a look. Spiral matrix 1, 2, and 3. So you're saying there's 3 of these? Linked list, binary search. Ooh, you know what? I haven't done a problem that requires a binary search. I should just add that to the list for stuff I'm going to do tomorrow. Here, whatever this is. Search a 2D matrix. I'll do this tomorrow. Stack. Generate parentheses. Oh yeah, the min stack. Also, valid parentheses is always just like a good problem to review. I'm pretty sure I've solved that before, but I should just put that. Yeah, I solved that in 2020, in May of 2020, but I should do it again. It's good practice. Sliding window. 2 pointers. Okay. Let me take a look at this. Given an m by n matrix, return all the elements of the matrix in a spiral order. Monotonic stacks. Yeah. I had started looking at those as well. LeetCode monotonic stack. I solved a problem called next greater element. Right here, like these two, I solved both of those with monotonic stacks, but there's a bunch of problems here that I need to do. So, yeah, thanks for flagging that as well. So for this problem, I think so I don't think I've solved this. No, but I think I'm familiar with at least one way to like think about it, which is you're kind of keeping track of the 4 corners of a rectangle that's getting smaller and smaller as it approaches the center of the matrix. So you like go around the whole outside in a rectangle, then you bring them all in by one, you go around again. So I can try to implement that, but I don't think I've solved this one before. So M would be matrix 0.size. They give you, yeah, they guarantee that it's at least 1 cell. And then they want, obviously, the answer. So we need our bounds, so we could have like int I guess I can keep track of like the top left and the bottom right. So I top left equals 0. I'm going to use I and J as my like you know, in place of X and Y or R and C. J top left equals 0. Int I bottom right equals n minus 1. Int J bottom right equals m minus 1. And then you're doing you could probably represent this as a while loop, like while these don't like go past each other. All right, 360 no hope. Yeah, thanks for hopping in and telling me about LeetCode, and thanks for the follow, and yeah, hope you come back. So while I top left, so let's see. Let's try to draw this out using text. So up here, actually let's not draw this out using text. Let's like actually draw this out. I have the means here to do that. I've got a little drawing tablet. So basically we've got our matrix. And we've got the top left, the bottom right. And what we're doing is we're going to be going around it in this direction in layers, where we're keeping track of the top left and the bottom right of each layer. And so we're going to have like this, which is our IJ, and then here we've got KL, although in my code I have them called differently. And so I is going to be increasing, J is going to be increasing, K and L are going to be decreasing. So basically like these corners are coming inwards. And so it's possible for I to equal K, but I cannot go past K. So that's what I'm trying to figure out right now. So in our while condition, we want to have like, hold on, let me take this fucking glove is uncomfortable. So why the I in the top left is less than or equal to the I of the bottom right. And then the same thing for the J. So while, so the J of the top left also needs to be less than or equal to the J of the bottom right. Okay, so while that's the case, what we're gonna do is we're gonna go around a full circle. After we go around a full circle, it's plus plus ITL plus plus JTL minus minus IBR minus minus JBR. But first, we gotta go around. We gotta go in the circle. So I think we can probably represent that just as four for loops. So for int I equals the I of the top left. I needs to be less than or equal to the I of the bottom right. Yeah. Plus plus I. And what we do is answer dot pushback matrix of I J top left. So the concept is definitely sound, but getting all these variables right is going to be the tricky part of this. So what we're trying to do right now is go across this top, all the way across the top. And IJ, I is the row, right? And J is the column. So this actually needs to be, we need to be going J from J of the top left, J is less than J of the bottom right, plus plus J. And then it's I of the top left, J. And that should sweep all the way across that top layer. Now we need to go down all the way to the bottom, but we don't want to count the top right cell twice, so we have to skip one. So for int I equals I of the top it's it's I of the top left plus 1. So we're skipping that row. I is less than or equal to the I of the bottom right plus plus I, and then answer.pushback matrix of I, and then j of the bottom right. Yeah, that feels good. Okay, now we need to go all the way across the bottom backwards. So for int j equals j of the bottom right minus 1, because we want to skip that bottom right cell. J is greater than or equal to j of the top left minus minus j, and then it's going to be the I of the bottom right, j. Okay, one more, and then we'll find out how close we actually are. Now we need to go back up. So I starts off at I of the bottom right. Minus 1. I is greater than or equal to the I of the top left. Plus 1. Because we don't want to count that top, we don't want to, count that top left cell twice. Minus minus I. And then answer.pushback I, and then it's j of the top left. Whew. Move that up there. Okay, run code. How close are we? So we passed. Do we pass both of the examples? No. No, we don't. Okay, but we're definitely on the right track. That I can guarantee you. There's just probably some issue with the boundaries that we'll have to debug. So let's focus on the test case that's failing, which is this one. So for this test case, which is example 2, what am I doing wrong? Oh, I have an extra number at the end. So it should end at 6, 7. But I have 6, 7, 6. This is definitely going to be the last problem of the stream, unfortunately. Hopefully I'll get it. I need to solve it in like the next 10 to 15 minutes. What's the mistake here? So if you, let's think about how the specific example with regards to how my algorithm is written. So 5 would be the last element that gets added to the answer from the outer layer. So then the 6, 7 is starting a whole new layer. In this case, the layer is 1 row tall. So so the way that the code is written, obviously it's not right now, but what it should be doing is it should just go through that row once and then not do anything else. But one of these for loops is registering that 6 again as a number that needs to be counted. So I is greater than or equal to, is it this? What's wrong with this? This looks right, isn't it? Okay, let's do this. It'll actually help to use the debugger for this, because what we can do is we can just breeze through the outer layer and then focus in on what the code is doing during the 6-7 layer there. So we set a breakpoint. Let's debug. So we get in here. Answer has nothing in it yet. Okay, so we skip over these, and so far we can update those pointers. So far it's right. 1, 2, 3, 4, 8, 12, 11, 10, 9, 5. So then when I step over, we come back around, and let's see what happens. So our I and a J are 1, 1, and IBR, JBR, excuse me, are 1, 2. So that's correct. That part is completely right. So because of that, this while loop will pass and will come back in to go again. Okay, now this first for loop here is the for loop that should be responsible for the 6 and the 7 going into the answer. So if I step over it, now we actually have the right answer. So we have our 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, and we have our 6, 7. But here's the problem. One of these other 3 for loops now is going to add another 6 on the end, and that's not correct. So let's figure out which one it is. It's this one. This for loop. Do we only do that? We could add some if statements, honestly. So, you know what we can do? If the layer is just one row, then this top for loop is all we need to do. So what I can do is only run these if we have more than one layer. So if I of the top left equals if I of the top left is less than I of the bottom right. If I of the top left is less than I of the bottom right, then that means we have more than one layer, because otherwise those are equal. So I can actually put these 3 for loops here in there, and that will work. Now, here's my concern. I think that this change will fix it for that test case. But what about the test case where there's just one column? I might have to add something for that too, but let's just see how we did. So we run the code on that test case. Now it's right. We can run the code on both of the test cases we know. Those both pass, so we submit, and I think I'm going to fail. Yeah, I can't be bothered to come up with my own test cases right now. I just want to see why LeetCode says my my solution is wrong. So exactly as I suspected, we now fail on this test case for a single column. What should we get? We should get 796, but I get 7969. And I'm just going to debug and see which for loop is responsible for that. Well, I could probably figure it out. So yeah, let's debug. Debugging is fun. Run the debugger. Okay, so this first for loop will put 7 in the answer. Then that if statement passes, so we come in here. Now this loop is trying to go, oh, this loop will put the 9 and the 6. Ah, so we only do these two. I think this will actually work. But we only do those two loops if we have more than one column. So if j of the top left is less than j of the bottom right. So if we have more than one column, then we do these loops. So now we pass the test case. Do we pass all the test cases that we know of? I think we should. Okay, now we submit. There it is. That's how you do it. Runtime, really good. For someone was telling me this in chat the other day, but for problems that don't have much test data or that just run really fast, the runtime here doesn't really mean much. Like, I definitely haven't written the fastest possible solution of all time, but just because of how LeetCode measures it, their measuring has like a certain, the accuracy is not always reliable, basically. So I bet if I submit a few more times, I'll actually get, yeah, there we go. There's like a runtime of 4 milliseconds, runtime of 6 milliseconds. But anyway, and then we went back to a runtime of 0 milliseconds. So that's how you do it. The memory use is good. So they all have about the same memory, and we're doing better than 70% of C++ submissions. This is a linear time solution. Even if it doesn't look like it, this is O of n time, and also O of n space. Yeah, it's O of n space because we have to create the answer array, which has the exact same number of elements in it as the matrix does. But yeah, every single cell gets accessed for its value at most once, which is why we have a linear algorithm here. It is pretty nice. It's cool to be able to think about this problem in this way. Like, you're just taking you're going around these layers, and once you finish a layer, you're just bringing in the top left and the top bottom right coordinates, and then you do the next layer. And I imagine that if we look at the solution, that's probably what they're going to recommend. So approach 1, set up boundaries. Oh, okay. So this is the same solution that I did, but they had a slightly nicer way of like, I don't really like my eyes this right here, but they have like up is not equal to down, left is not equal to right. So they're up, down, left, right. That's equal to my ij of the top left and my ij of the bottom right. And then you can see here they do the exact same thing. So they just update those four. Time complexity is m times n. Oh yeah, I mean, when I said n here, I meant like size of the input. But if you want it in terms of the dimensions of the matrix, it would be m times n. Space complexity. Okay, so they say space complexity is 01. I guess mine would be 01 as well, because they're saying that the output array doesn't count. Okay, approach 2, mark visited elements. I see. So basically that's a kind of a cool way to do it. Like, you're basically programming a little snake that's just going around, and every time it encounters somewhere it's already been, it changes direction in a clockwise fashion, right? So you're going to the left, you're going to the right. As soon as you hit either a boundary of the matrix or you hit a visited cell, you turn clockwise, so then you're going down That's a cool way to do it that I didn't think of. And then it goes without saying, but after every cell, you also mark it as visited. That's cool. Okay, so yeah, like I said, short stream today. I need to go right about now. Thanks for the 2 follows today. Those came from 360 No Hope and Dragon 96. But yeah, anyone else who happened to tune in at any point, thanks for tuning in. I'll be back for more of the same tomorrow. More LeetCode, more Clash of Code, Codewars, AlgoExpert, like just the general technical interview preparation grind. So yeah, that's what's going to be happening tomorrow and for the foreseeable future, for the undefined future. Yeah, thanks for being here, and I'll catch you tomorrow. Peace.